I'm going to put my hands up and admit it. I've been gatekeeping one AI research tool for the last couple of months, not because it's secret or hard to access. However, because it genuinely made my research workflow faster, I wanted to test it thoroughly before recommending it publicly. Anara came onto my radar a while ago, and at first I assumed it would be just another ChatGPT wrapper, so I did what I always do. I used it in real research work for weeks, not for one afternoon. I tried it on messy, PhD-level questions, where most tools either provide generic summaries or confidently hallucinate. Today, I'm finally going to show you, Anara, on my screen, exactly how I use it, and I'm going to test it live on a PhD topic, skeletal muscle physiology. In this walkthrough, I'll do 3 things. Run a deep search to build a PhD-level starting point in minutes. Prove the trust part by forcing a situation where the tool should refuse to answer if the paper doesn't contain the information. Do the power move, multi-paper synthesis to identify disagreements and gaps in the literature, then write a literature paragraph with citations. All right, let's start with the core workflow, because this is what makes it actually possible to write a solid research paper in one focused day instead of 3 exhausted months. I'm going to show you how I use one AI research tool to do deep search, check trust, find gaps, and finally turn everything into real writing with citations, all on a real topic. Skeletal muscle hypertrophy mechanisms in humans. It sounds simple, but at the PhD level, it quickly becomes a maze of pathways, cell types, and training variables. And without a system, you can lose weeks just trying to get oriented. So the first thing I do inside this tool is run a deep literature search, not just type a casual question. I paste in a very specific prompt. Run a deep literature search on skeletal muscle hypertrophy mechanisms in humans, focusing on mTORC1 signaling, ribosome biogenesis, satellite cell involvement, and training variables. Prioritize systematic reviews, meta-analyses, and mechanistic studies from the last 5 years. Return an overview plus the most relevant papers. On screen, I'm not looking for a pretty paragraph. I'm looking for structure. I want it to expand the scope properly, surface the right clusters of keywords, and, most importantly, return papers I can actually click and read. DOIs, titles, and links, not just vibes. When the results come back, I immediately turn them into something closer to the backbone of an introduction. I force it to prioritize with a second prompt. From your search results, shortlist the top 12 most relevant papers for a PhD literature review on hypertrophy mechanisms. For each paper, give 1 sentence on why it matters and what unique contribution it adds. Most researchers don't struggle to find papers. They struggle to decide what deserves attention first. That 1-sentence justification forces the AI to explain why each article earns a place on my reading list, and within a minute, I can see which ones focus on mTORC1 in humans, which deal with satellite cells, which speak to ribosome biogenesis or training variables. Already, I'm not just collecting PDFs, I'm curating a serious starting set for my paper. Next, I want to see whether this tool can behave like a real research assistant or if it's just summarizing abstracts. So I push it into the uncomfortable zone, disagreements in the literature. I take the same topic and ask, summarize the current consensus and the main disagreements in the literature on whether satellite cells are necessary for human skeletal muscle hypertrophy. Cite sources for every key claim. Now I'm looking for 2 things at once, a clear consensus summary and a structured map of where papers disagree, tied to specific citations. If it can show me that some human studies suggest hypertrophy can still occur when satellite cells are limited, while others show blunted growth, and link each claim to specific papers, that's a huge win. It means I don't have to read 20 articles blindly just to find out where the real argument lives. To lock this into something I can reuse, I ask for an evidence map. Create an evidence map table with columns, mechanism, key markers or pathways, human evidence type, like RCT, biopsy, tracer, and strength of evidence, plus 2 to 3 citations per row. Keep it concise, but PhD level. What comes back is a compact mental model of the field. 1 row for mTORC1, 1 for ribosome biogenesis, 1 for satellite cells, and 1 for training variables. A table like this turns random reading into targeted reading. You instantly see which mechanisms are strongly supported, which are debated, and which still look thin. And before we go further, quick reminder, if you want to try this one AI tool the way I'm using it, I'll leave the link in the description so you can copy this exact workflow onto your own topic after you finish the video. Now let's move from nice search results to actual proof, because this is where most AI tools fall apart. A general summary can sound impressive, even if half of it is made up. The real test is what happens when you open one specific paper and ask the AI to stay inside that one source. So I click into one of the shortlisted articles and give it a strict prompt. Using only this paper, produce a structured summary with background, methods, key results, limitations, and what this changes for hypertrophy physiology. Quote or point to the exact section for each key result. Here I'm watching very closely. Does it actually use the methods and results sections, or does it invent details that don't exist? Does it point me to figures, tables, and paragraphs, or does it just talk in general terms? When the answer comes back, and each key result is tied to a specific figure or paragraph, and the limitations clearly come from the discussion section, that's when I know I'm dealing with more than just a chatbot. If I can't trace it, I don't trust it, and I definitely don't put it into a manuscript. To really test trust, I have to give it a question where the safest answer is, I don't know from this paper. So I stay inside that same article and ask, using only this paper, what is the exact recommended daily protein intake in grams per kilogram per day for maximizing hypertrophy in trained adults? If the paper does not specify a value, say you cannot answer from this paper. This is a trap on purpose. A hallucinating system will confidently give me a number it pulled from somewhere else and sound very sure. A cautious research assistant will say, I cannot answer from this paper because it does not provide an explicit recommendation. That is exactly what I want. In a scientific workflow, an AI that knows how to say, I don't know from here, is far more valuable than one that pretends to know everything. That's how you protect your paper from subtle but dangerous nonsense. Once I'm convinced it can stay inside the walls of a single paper, I move to the power move, multi-paper synthesis. This is where human researchers usually lose days, because holding several complex articles in your head at once is hard. I pick 4 papers that represent different angles on hypertrophy, maybe a mechanistic review on mTORC1, a satellite cell study, a trial on training volume, and a human biopsy or tracer study. And then I ask, across the selected papers only, identify points of agreement, points of disagreement, and the strongest evidence each side uses regarding hypertrophy drivers such as mTORC1, satellite cells, and ribosome biogenesis. Provide citations tied to the specific paper for each point. If the tool is good, this is where it shines. It tracks which claim comes from which paper and shows me not just that there is disagreement, but exactly how each study supports its position. Very quickly, I start to see patterns, which mechanisms everyone agrees are central, which are still under investigation, where human evidence is strong, and where we are still leaning heavily on animal data. Instead of a fog of separate findings, I have a structured map I can almost drop straight into my discussion section. But the real PhD level question is never just what do we know? It's what don't we know yet, and what can I realistically test? So I use those same 4 or 5 papers and push one step further with another prompt. Based only on these selected papers, what are the most important gaps in the literature, and what would be 3 high-impact PhD studies to address them? For each proposed study, specify a clear hypothesis, study design, primary outcome measures, and feasibility constraints. Now, the AI has to act like a planning partner. It might suggest, for example, a longitudinal human study testing different resistance training volumes while tracking ribosome biogenesis markers, or a trial that combines different protein intake levels with hypertrophy training in older adults with potential anabolic resistance. For each idea, it needs to spell out what we would measure, roughly how big the sample should be, and what practical limits we might face. It turns literature reading into research planning. You are not just absorbing what others have done, you are sketching what you could do next that actually sits on top of the current evidence. Once I have that level of understanding, I'm ready for the payoff that most people actually came for, turning all of this into writing. I don't want a random essay. I want a usable literature review paragraph that integrates consensus, disagreements, and proper citations. So I give the tool one more focused instruction. Write a 180 to 220 word literature review paragraph on skeletal muscle hypertrophy mechanisms in humans, integrating consensus and disagreements. Use APA-style in-text citations and provide a brief reference list. Do not invent sources, only cite papers you can link. That last sentence is crucial. I am telling the system that if it cannot connect to the source, it must not cite it. When the paragraph appears, I check 3 things. Does it combine mechanisms into a coherent story instead of just listing them? Does it handle disagreements honestly instead of pretending the field is perfectly aligned? And do the citations match the set of papers we actually used? If the answer to all 3 is yes, I have a paragraph that I can paste into my draft and edit or use as a strong starting point to rewrite in my own voice. That's where one day becomes realistic. You are not staring at a blank page, you are editing solid, structured text grounded in real sources. As a final step, there is one more move I love using, especially when I know I will have to live with this topic for months, turning the whole session into active recall material. Reading alone can trick you into feeling like you understand something when you don't. So I take all the work we just did on hypertrophy and ask for learning tools, generate 12 PhD-level flashcards, and a 10-question quiz on skeletal muscle physiology related to hypertrophy, including mTORC1 regulation, anabolic resistance, satellite cell biology, and training variables. Include answer keys and 1 to 2 citations for any factual claim that is contentious. Instantly, I get a set of question-answer cards I can review, plus a short quiz I can take tomorrow to see what actually stuck. This is not just study material. It is also a way to check whether the AI has been consistent in how it talks about mechanisms and evidence across the whole workflow. If something in the quiz contradicts what I saw earlier in the evidence map or the summaries, that is a sign to go back and double-check. If everything lines up, I know I've built not only a literature base and a paragraph, but also a mental model I can carry into my next chapter, my next grant, or my next presentation. That is how you turn one AI tool from a fancy chat box into a real partner for writing a solid research paper in a single day. Deep search, traceable summaries, strict trust tests, multi-paper synthesis, gap-focused planning, citation-aware writing, and finally, active recall. So the knowledge actually stays in your brain instead of evaporating the moment you close the tab. After using an era like this, deep search, paper-level grounding, multi-paper synthesis, here are the 5 reasons I think it's worth trying for skeletal muscle physiology research. It helps you go from a vague topic to a structured PhD-level search scope fast. It forces traceability by keeping you tied to papers instead of vibes. The trust test behavior matters. Refusing to answer from a paper is a feature, not a bug. Multi-paper comparison is where you win time. Agreements, disagreements, and gaps become visible. It can convert research reading into usable writing outputs and study materials in the same workflow. If you want, I'll leave these exact 10 prompts in the description. Subscribe if you want the next video, where I build a full skeletal muscle physiology mini literature review outline from scratch.